Welcome to FMSP Online Revision. This session is for OCR D2 and the topic that we're going to be looking at is matching and allocation problems. So we'll start by having a look at the specification for this topic and then we'll work through a couple of exam questions to try and help you get as many marks as possible when it comes to the exam. So candidates should be able to first of all, represent a matching problem by means of a bipartite graph, and secondly, use an algorithm to find a maximal matching by the construction of an alternating path. So those are our matching bits, and then we've got to interpret allocation problems as minimum cost matching problems, and use the Hungarian algorithm to find a solution to an allocation problem including the use of dummy row or column, use the covering method to check whether a matching is maximal, and augment and interpret a revised cost matrix. So for the Hungarian algorithm, it is important that we remember that it is a minimizing algorithm. So if we're asked to maximize, then we need to alter our matrix, find the largest number, subtract every element from it and make it into a minimum problem. And also this business about dummy rows and columns, then remember that the Hungarian algorithm uses square matrices. So if we haven't got a square matrix, then we may have to introduce the row or column. So let's have a look, as I say, at some questions and see if we can draw out those main points. So the first one we're going to look at is a matching question. So these questions do tend to be fairly similar. So you've got mother and father and 4 children. They're working out about breakfast cereals with a little selection pack, and certain people like certain cereals, etc. So the information is given in a table, not always in a table, but in this particular case it is. We've got to draw a bipartite graph to represent the information. And having got that, we're given information about what we would refer to as an initial matching. So we're told that Adam gives cornflakes to Fiona, Oaty bits to Edward, rice pips to Donna, choco pips to Charlie and the wheat biscuits to Barbara. However, this leaves honey footballs for Adam, which is not a possible pairing. He doesn't like them. So we're asked to draw a second bipartite graph to show this incomplete matching. So it matches 5 people up to 5 cereals. There were 6 people and 6 cereals, so it's incomplete at this stage. And then in part 3 we're asked to construct a shortest possible alternating path from 6 to A and hence find a complete matching between the cereals and family members. And just be careful, it does say write down which family member is given each cereal with this complete matching. And then Adam decides he wants cornflakes, so we then have to construct an alternating path starting at A based on your answer to part 3, but with Adam being matched to cornflakes, to find another complete matching. And we've got to write down the family member, which family member is given which cereal. So there are actually only 6 marks for the total question. There was 1 for part 1, 1 for part 2, and then 2 for each of these ones where we're getting alternating paths. So not a lot of marks, but you just need to be careful that you write down all the information you're asked for and that you get these 6 marks. So the first thing you're asked in part 1 is to draw a bipartite graph. Now this is what will be given to you on your answer sheet and on the inserts. So you will have a diagram like that, and it's just a matter of going through each one. So for example, cornflakes could be for Adam, or it could be for B, Barbara, and so on. Or F, Fiona, also likes cornflakes. So we could match those up and so forth. So that's what you would get on the insert. I've just going to show you the completed answer. Fairly simple. It's just a matter of making sure that you do just check that you've got that diagram correct. Always worth a check, because if that's not right, then you can go wrong later on. It then says Adam gives cornflakes to Fiona So cornflakes to Fiona is going to be a match, so that we could put in there. Oaty bits to Edward, and so on. So again, you have got to draw this. This is the diagram that will be given to you. You just have to complete it so that you end up with your incomplete matching looking like this. So I haven't drawn it all in, but I am just because I think that's fairly straightforward, just as I say, be careful. So that's our second mark, so 1 mark for each of those. And then if we look at part 3, it says construct the shortest possible alternating path from 6, which is here, unmatched vertex on the left, and we have got to try and match that up to an unmatched vertex on the right. So that's what we're being asked to do, and hence find a complete matching. So I have marked in dotted lines. You're not allowed to use colours. So what I've got here is I have put in the incomplete matching that we had from part 2, and I think that makes it easier for us to follow. So the alternating path says we start at 6 and we go along an unmatched edge from 6, so the only place we can go to is B. And when we get to B, we're meant to go along a matched one in the initial incomplete matching, so that will be B to 3. So I'll put an equal sign there because that was in the initial matching. Then from 3 we'll go to D, and from D we'll go along an edge which is in the initial matching, so that will take us to 2, and then from 2 to C, from C to 5, and from 5 to A. So just check that you can get from 6 to A, and it's alternating because it's not in the initial matching, in the initial matching, not in the initial matching, in the initial matching, and so on. And then the algorithm tells us to change these round. So if it wasn't in, it is going to be in, and if it was in, it's going to be out. So I'm just going to change each of those. And now we'll see if we've got a complete matching. So that means that Barbara is going to have these honey footballs, that D, Donna, is going to have number 3, which is the wheat bisques, and that C, Charlie, is going to have 2, which is rice pips. And the last one we've got is A, which is Adam, and Adam is going to have 5, which is choco pips. So Adam is here. And then just check, we can still have, Fiona can still have her cornflakes. That was in the initial matching. I'll put a little star just to remind you that that was in the initial matching. And then Edward, if you look, check, Edward also can still have his oaty bits, and that was in the initial matching. So we now have a complete matching. And there was 1 mark for showing your alternating path clearly, and 1 mark for writing down which member is given which serial. So you do need to write that down. And now we'll move on to part 4, where it says that Adam decides that he wants cornflakes. So we've got to construct an alternating path starting at A based on your answer to part 3. Now this is the answer to part 3. But if Adam wants cornflakes, then he's not going to have choco pips. So I've sort of crossed that out. And Fiona, therefore, cannot have cornflakes if Adam wants them. So what I've done is I've just put these other 4 matchings that we had from part 3, and I've shown them on our diagram. And now what I'm going to try and do is I'm going to match up Adam with cornflakes, which is what we need. So we're going to have to start here with Adam, and also we have now got choco pips, and that needs to be matched up as well. But we know that Adam is having cornflakes, so we're going to go along an unmatched edge, but it has to be one with cornflakes. So if we do that, so we'll have Adam going to cornflakes, which is 1, and then we will want to go from cornflakes to Fiona. Now Fiona was on that initial matching, so perhaps that might be better if that was put in. She was in the initial matching, but she's now not going to have it. And then Fiona, we can go along an unmatched node to OT bits, which is 4, and then from 4 to E, which is in our initial matching, and then from E to 5. So that's our alternating path again, so we will now just change those. So Adam definitely gets his cornflakes. So Adam is going to have cornflakes, Fiona is going to have OT bits, and Edward now is going to have choco pips. Notice then that the others will stay the same. So if we just write that, if we look at the next slide, so this is the matching that we've just done. So Adam's going to have cornflakes, Fiona has OT bits, Edward has choco pips, and then the others are as they were. So we now need to write all that out. So again, just 2 marks for that question. So 1 mark for this working here and showing your alternating path, and 1 mark for writing out which family member is given each cereal. So as I say, only 6 marks, but do be careful, you want to get those all sorted. So the next question we're going to look at is the Hungarian algorithm question. So you've got an investigation into a burglary. Agatha has 5 suspects who were all known to have been near the scene of the crime, each at a different time of the day. She collects evidence from witnesses, draws up a table showing the number of witnesses claiming sight of each suspect. So you look at the table and you say, oh gosh, 10 of them saw Dr. Silverbirch at 2 p.m, which is interesting, you know. So we've got the information there, so just check that you understand what it means. What we're asked to do is we're asked to use the Hungarian algorithm on a suitably modified table, reducing rows first to find the matchings for which the total number of claimed sightings is maximised. Show you're working clearly, write down the resulting matching between the suspects and the times. Now notice here we do have 5 rows and 5 columns, so it is a square matrix, so we don't have to adjust it by putting in any dummy rows and columns, but on the other hand we are being asked to maximise, so we're going to need to alter it to make it into a minimising problem. It then says further inquiries show that the burglary took place at 5 p.m. and that Dr. Silverbirch was not the burglar. Who should Agatha suspect? So let's just have a little look and see how we would approach that question. So as I say, the first thing is we've got to use the algorithm on a suitably modified table. So we need to look for our largest entry here, which is a 10, and we subtract every element from that 10, so we make it into a minimising problem. So I'm going to just go through the table quickly and do that. So we're going to have 7, 6, 8, 3, 9, 504, and 2 more 4s, right? And so all we're doing is we're taking each of these entries away from 10. 7, 5 and 7, 4, 2, 6, 2, 7, and 2, 2, 3, 6, 7. So that now is our modified table. It then says we've got to reduce rows first. You're not always told the order in which to do things, but when you are, you must do it that way. So let's have a look. So this is our table. I've just copied that table onto this slide. Notice that I haven't got the labels anymore, so I've just got a 5 by 5 table here. So we're going to reduce rows first. So when we're reducing rows, we're looking for the smallest entry in that row, and we're going to take away that from every element. So a 3 here, nothing here, a 3 here, a 2 and a 2. So we're going to reduce our rows by -3, by 0, by -3, by -2, and by -2. So I'm just writing that down so that if I make any silly mistake, at least I've shown what I'm doing. And if we put those in, then we'll get 4, 3, 5, 0, 6, 5, 0. So this row doesn't change. And then the next one we're taking away 3, so it's 3, 0, 4, 2, 4. Taking away 2, so it's 2, 0, 4, 0, 5. And then 0, 0, 1, 4, 5. So we have now reduced our matrix by rows. And the next thing we need to do is reduce it by columns. Now notice that we can't reduce the first column or the second column or that fourth column because their lowest entry is 0. So those ones are not going to be reduced. They are already in reduced form. So we'll take 1 away from the third column and we'll take 4 away from the fifth column. So if we just check those, we've got 4, 5, 3, 2 and 0, 3 and 4 zeros, and then we're taking 1 away from here, so we'll have 4, 3, 3, 3 and 0, nothing away from that, so 0, 4, 2, 0, 4, and 4 away from this last one, so that's 2, 0, 0, 1, 1. So we now have reduced by rows and reduced by columns. The Hungarian algorithm says what we have to do now is we have to see how many lines it takes to cross out all the zeros. So that's the next little bit that we're going to do. So the thing is to look for rows or columns that have lots of zeros in them. So if I were to take this one first, then I can cross out 4 of those zeros just with that line. We've got 2 zeros here, so I'd use a line there to get rid of those, and I've 2 zeros here to get rid of those, and I can now sort those 2 zeros out by crossing that row. But the thing is, I've needed 4 lines needed, and it's a 5 by 5 matrix. So that Hungarian algorithm tells us that we have not got an optimal solution yet, because we need 5 lines in order for it to be optimal. So we need to augment. And we augment by finding the smallest uncovered element. So that in this case is going to be a 2. And again, try to remember you have to show your method, so I'm trying to sort of mark these things on. And where we're going to reduce every uncovered element by 2, and we're going to add 2 on to any element which is crossed by 2 lines, covered by 2 lines. So 2 is the smallest element, so I'll just write that there too, so we remember why we're doing that. And then we'll augment. We're ready now. So we are going to take 2 away from any uncovered element, so it's 2, 3, 1, 0, and we don't touch this entry at all. Now I've brought my labels back in because we're just about finished and I thought it would be useful to have them, so don't get confused by that. So this is our first column now. This column we don't change these entries, but we do add 2 on to this entry because it's crossed by 2 lines, covered by 2 lines. And then we'll take 2 away from each of these, so it's 2, 1, 1, 1, and that one doesn't change. This doesn't change, except we add 2 on to that because it's covered by 2 lines, and again the same here, 2, 0, 0, 1, and we add 2 on here. So we have now augmented. So we try again to cross out the zeros by as few lines as possible. So here we have got 3 zeros, so I'm going to do that one first. We've got 2 there, so I can get rid of those. We've got 2 here, and we've got 2 here. Now you can try it and do it different ways. You don't have to do it exactly the way that I've done, but you should find that whatever way you do it, you will always end up with needing 5 lines. That's the important thing. So now we have to try and find the way in which it's going to be a minimum. So again, just go to the rows where you've only got 1 0. Now it looks as though the only time that Mrs. Rowan could be picked would be at 4 p.m. So I'm going to put that in the table. There are 2 entries for Dr. Silverbirch, 2 and 5. There are also 2 entries for Mr. Torn, which are identical, both 2 and 5. So I'm going to put both of those in because obviously they could be interchanged, couldn't they? So once we've actually done that, so we've got 2, 4 and 5 o'clock, then Miss Willow could be 1 o'clock or 4 o'clock, but that's so we're going to have to put that in. I better circle these. Might be easier to see. So I think the only possible time for Miss Willow is 1 o'clock, and that means Sergeant U at 3 o'clock. So there are, and it is important to see, there are 2 possible ways in which we could allocate these, match them up. So Mr. Rowan was 4 o'clock only. Miss Willow was 1 o'clock and Sergeant U 3 o'clock, but obviously we could interchange these 2. Now it is important that you actually write down both, because there were marks for each of those. So if we just go back and have a quick look at how the marks were allocated, you actually got 2 marks for making it and modifying your table, so it was a minimizing problem. 1 as a method and 1 for accuracy. So if you did make a silly mistake, you'd lose the accuracy mark, but not the method mark. You then got, in terms of reducing, you got a method mark for reducing by rows and a method mark for reducing by columns, and an accuracy mark for getting them correct. And then when you came to this next bit, you get a method mark for augmenting and an accuracy mark for doing it correctly. And then at the end here, you got 1 mark for each of these. So it is important, as I say, that you write down each of these. So 1 mark for this method and 1 mark for that. So a total of 9 marks altogether. And then the last little bit of the question said, further inquiries show that the burglary took place at 5 p.m. and that Dr. Silverbirch was not the burglar. Who should Agatha suspect? So if we go back and see, then the other person was Mr. Torn. So That is the important bit, and that's 1 mark for writing down Mr. Thorne. So, as I say, 10 marks in total for that question. Just make sure that you show all your working carefully. So I'm going to stop this session here and just remind you that, as always, the way you revise mathematics is work through lots of questions. So do just make sure that you do lots of problems involving matching and Hungarian algorithm. They're not a difficult topic, but you just need to make sure you don't make any silly mistakes, because you can lose marks very easily.